Hello everyone, welcome to another little recreational coding thing. I did not steal that. I did not steal that intro. Okay, so today we're going to be looking at run length encoding, and the only reason is because I want to get into a little bit of like compression stuff. Like I find the idea of the math behind compression, like information theory, I guess, uh, quite interesting. I had a semester-long course on information theory, but I did not a lot stuck. At least not now. It's a couple of years later after that course, so I don't really remember that much. But um, I did pass with a very good grade. Let that be known. But and I also see my mic oversteering a little bit again. Like last video was wild. I think I'm just talking way louder when I'm excited. Anyways, keep an eye on that. Okay, so today we're going to write a run length encoding algorithm in Rust. And then that's going to be the entire video. And the next time we're going to see, what can we do next? Is there other, like I was looking at lossless compression algorithms, and I just find run length encoding to be one that's very simple because I actually remember it partially. And so in this video, we're going to do three things. We're going to first figure out how run length encoding works because I don't remember. And I'm going to just literally run through how I would go about finding out, okay, I have a name, I have this name, right? How does this work? So I'm gonna try to look up how it works without looking up actual solutions, right? Without using AI if I can, because that's also cheating and probably wrong. And then step 2 is going to be implementing it in Rust, and step 3 is going to be writing tests for it. Well, step 2 and 3 kind of blur together. Yeah, the important part is here that we're going to write some tests, and we're going to write some code, and we're going to make a library, and we're going to publish that library at the end of it, hopefully. And I hope it's not going to take too long. Thank you for being here, and if you enjoy this kind of video, make sure you subscribe to the channel, because there's a lot more like this on the channel and coming up, and you'll like it. Anyways, let's go. So run length encoding, and I just kind of went over this. It's a little bit of history in there and shit like that. But essentially, I think the way that it works is that it kind of shows here. Like, I think the way that this kind of compression works, and I'm going to essentially just assume that you also don't have any idea how it works. So I'll try to explain it. So the idea is I want to compress some data, right? Like, this is some text I want to compress. And realistically, this is compressible because it repeats, right? And in its most simple form, something like this, or let's actually do it simpler. So this is going to be my data. Okay, so I have some data that has repeating segments. Let's actually do a little hello in here. So we're going to just try to do a manual sort of run through of the run length encoding algorithm. See if we can figure it out by hand by just like looking at this and looking at this absolutely scuffed Python implementation. Like, I like Python. It's the first language I ever learned, I think, but well, apart from fake languages like BAT or whatever, but it is actually really fucking ugly. Like, I like Rust because it has like very expressive ways of doing stuff, but it still follows very simple rules. Like, everything's an expression, stuff like that. More or less, anyways. Okay, so the idea of run length encoding, I believe, from what I can see here, is that it returns something like this into something like this. So I guess you would have like 4A, then 1H, 1E, 1L, 1L, 1O, and then you would have 4Bs and 5Cs. Right, and you can see that's a little bit shorter. It's a little bit shorter than this. And that's interesting because, like, for this data, it didn't really compress it that much. But given an example where we have more repeatable data without the hello, for example, we then have 4A, 4B, 5C, and that's it. And now we pretty much halved the amount of bytes that we need to have to store this. And to re-expand it, we just have to go through it. We have to go, okay, I have 4A's and then 4B's. Whoops. And then 5Cs, right? And that seems reasonably simple to implement, right? That's the entire idea of run length encoding algorithms. There's a couple things that come to mind immediately. Number one, I'm just monitoring the mic here. How do I optimize this? Because this seems um, pretty fast, but are we guaranteed to have, we're not guaranteed to have less data than what we started with. So we do need to technically check if we need to allocate more. The second thing is there seems to be like, okay, so there seems to be a limit, right? So because the biggest, so in this format of run length encoding, which is not very good, where everything is just ASCII or UTF-8 or whatever, we can only store, like, so imagine this, right? So how do I encode that like that? I guess I have to, but then if I have this, what is this? Is it 411 A's? Is it 11 A's? Is it 411, 4 ones and then 1A? I guess that would be it, right? But that means that I can only encode up to 9, right? Because 9 would be the maximum. Or I could go up to F, right? So hex. I could say, okay, 0 to F is going to be how many, like, is going to be my prefix. So that's interesting. That seems a little broken. So we essentially have like 1 byte len, and then we have the like the sequence, which is also 1 byte. So this is a really, really bad sort of algorithm. So because like this can only, like, if I really have repeating data, it's only going to compress it so much, right? Like if I have this, which is like, how many is this? This is 51 characters. I can't go 51A because that would be 5 ones and then whatever this would be, probably nothing, because that seems wrong. So I guess we would have to split this up into like, 9A, 9A, and so on, right? Like until 9, 18, 27, and so on. Yeah, like until, I mean, this still compresses quite a lot actually. So maybe it's not that bad, but let's continue reading. So we traverse the input data, we count the number of consecutive characters, we store the character and its run length. So at this point, we don't really need to, like this is not the final output, I guess, right? Because we're just storing it. And then to decode, yeah, fair enough. So this is okay, so we have 12 W's, 1B, 12 W's, 3 B's. Okay, so right. So this is obviously more efficient than this. I don't mind this. Let's read this. So this can be interpreted blah, yeah. Binary files can be compressed with this method. Yeah, obviously this can work on binary files, right? So the output wouldn't be this. The output would be some sort of binary format where we can actually store up to 255 because, if we have, as I said, 1 byte length followed by 1 byte char, like data, I guess, then we can actually have, for example, 255 X's or some shit, right? Which is a lot better than 9. Right, so that would make sense. So we definitely want that binary format. Which of course wouldn't look like that. It would be like some unprintable character. Okay, what do we have? Newer compression methods such as deflate use LZ77, which is from 1977, isn't it? Yes. It's named after the 2 people who made it, Lempel and Ziff, which is fantastic. Generalization of run length encoding. Okay, yeah. So LZ77 would be probably the next one that we implement next video. But let's start with this one so we actually learn something here. Because I find that jumping straight to like, what is it called? ASN. It's called ASN encoding. ANS. This is encoding that's used in Z standard. Yeah, there is asymmetric numeral system. So this is used in Z standard, which is a fantastic compression algorithm. And but reading this article gives me a headache because like I have to keep track of so many concepts that I haven't heard of in a couple of years. I just find it easier to like I mean, this is nice. There's some code here and whatever, but like I find it probably much easier to just go from here to LZ77 and then to ANS and then so on and so forth, right? So let's do that. 10 minutes in. Fantastic. So one popular method encodes run lengths for runs of 2 or more characters only, using an escape symbol to identify runs or using the character itself as an escape so that anytime a character experiences twice, it denotes a run. Okay, so you could have like WW12B, WW12B, B3. So this would be like 1B, but this would be 3 Bs, and this would be 24 Ws. And okay, I see what you're saying. So the idea here is to have a special sort of sentinel character that tells us, okay, here, by the way, this is the end or this is the start of an encoding, like you know, part of the encoding, and the if it's not like that, then it's just raw data, which would really help with my previous example of going like hello, right? Because this would essentially just turn into 5A, 1H, 1E, 1L, 1L, or sorry, 2L, 1O, right? Which is the same length. Whereas with this new sort of idea, you would say AA5, hello. And well, actually, you wouldn't say that because you would have LL1, right? Well, this is where it gets interesting. Like, how do you discern between a duplicate duplicate thing of data? Because like, I guess you would have like LL1, which is 1 character shorter than the original. This still kind of stinks, right? Doesn't it? So okay, let's continue. Let's see. So I mean, we could use an escape symbol, right? You could use a special character, but that doesn't work if you have binary data, because how are you going to store that binary data if you like sort of take one of the possible numbers that you're going to store and treat it as something very different and special, right? Like a sentinel. This is called a sentinel, by the way, and Zig has a very nice Zig has actual notation for sentinels, which is fantastic, by the way. In language, try Zig. But anyway, so let's continue. Oh, okay. So this seems interesting. So this is a sort of optimization, right? You say, okay, I don't want to have escape symbols, sentinels, stupid shit like that. I just want to have like data and metadata, right? So this is our data and this is our metadata. And this would essentially tell us, okay, we have the actual data, and then we have numbers that tell us what parts repeat for how much or something, right? But how would this work? So we would have WWB, WWBB, WWB, WW, 12, 12, 3, 20, 40. Okay, so this is similar to this, except we don't mix data and run length, and instead we store them separately. I don't really see the point of that. I guess you could sort of guarantee that the data segment is shorter than the previous data segment, which makes compression very easy because you don't have to allocate very often for the compression, right? Because you can kind of sort of just allocate the same amount and then just go, that's gonna be enough. And then for the numbers, you're gonna have to allocate a little bit. Probably also pre-allocate the same amount of space. So you probably have one massive allocation that just allocates roughly what you need, but I guess you could always do that. Okay, there's a couple of variants. Sequential RLE, scanning from left to right, scanning vertically diagonal. Okay, so I see. So you could say, okay, my data is actually not line based. Like I don't have like linear repetition. So for example, I have data that looks like this: ABC, 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 ABC. And I know it always looks like that. Then I can say, okay, well, there's repetitions vertically, but not horizontally, really. I mean, the ABC repeats, but that doesn't count, right? So this was an interesting concept as well. How do we do that? So yeah, I guess in that case, you just write a completely different one, right? Or again, you could write it in blocks of some kind, but like, yeah, that's interesting. Okay, so then lossy. No, we can't have lossy. And this is often used for images, by the way. I just want to say that. This does not make a lot of sense for text. This makes more sense for binary data like images, and things where like you have large segments of repeating data. Like, for example, if you have a PNG image and like most of it is empty space because it's transparent, then you probably want to compress that in case, you know, like let's pretend PNGs cannot be compressed, which they can, but let's pretend they can't. Then you would take that data and you can sort of, you know, squish that together and only say, okay, there's a white pixel followed by 300 white pixels and then one black pixel again. So you don't have to store like a massive amount of data. So that's the idea here. Okay, let's build that. So I think we'll first start with this algorithm, this algorithm, the simple one, and then we'll go from there. So let's make a new project. And I think I'll actually put this on my server. So let me just quickly, whoops, connect to that. And make a directory for RLE. And I think that's plenty, so let's now connect to it. So that's source RLE. Okay, fantastic. So cargo init, and we'll get going. Oh, don't know what I typed there. Okay, so I don't think we need any dependencies. Let's just get going. So the first thing we want is probably, well, we probably want two things. So let's delete that and let's delete this and let's close that. God, can it please go away? Okay, I guess we'll just have a target folder. That's fine. Cargo init lib. And then we'll also let's just do it at the library first, and then we can later write an executable if you actually care. But right now we're just gonna have a library and tests because it's way easier. Okay, fantastic. So let's get going. So I guess we'll have a pub function encode text, which is going to take text, right? And I also want Clippy. How do you turn on Clippy? I've actually never turned it on, I think, but it seems like something I absolutely want. Yeah. How do I just, like, I just want the most aggressive Clippy. Like, just aggressive. Is that not possible? I mean, of course it's possible. I'm just trying to figure out how. And let's see. I mean, I guess maybe it's in here. I have cargo Clippy, right? Yes, of course I have cargo Clippy. I mean, I guess I can just run it like that. The idea would be that we can have pedantic, right? So we would have like, how does that work? Allow. So this is allow Clippy pedantic. Okay, and so now if I do like str string and I return like a string and then I do str clone, I think Clippy should scream at me, right? Am I wrong? No, it does not scream at me. Can I not just reverse it? Oh, no, I can't. Oh, it's called rev, isn't it? Iter rev collect. Okay, I don't know. I'm just trying to get Clippy to complain, but I guess it won't. Okay, so encoding text, I think for now, actually having this is not a terrible call. I know it's a little weird that we return an allocated string here because, but it's encoding text. So let's pretend it's UTF-8 and that's, you know, well, not, but yeah. So I guess we want to just iterate through the, let's see. I guess we want to go through and start counting. It seems like a fucking lead code in a question. You know what I mean? It's like lead code easy or some shit. So, so we encounter a character, and from there on we start counting. So let's actually do that. So our current character is going to be whatever the first character is. So if str is empty, we're going to just return string new, because I don't think we care much here. And then I need to turn off Copilot because I do not need that. I'm trying to learn. Yeah, see, it's being stupid. Let's just reload the file. Okay. So current is going to be the strings first. Is it get? Yes. Okay, so that does exist, does it not? No. Oh, sorry, char is nth. See, I haven't not even ever done this. So this is why I want to start with like a very simple sort of example, because I don't think I've ever written like proper algorithms like this in Rust, except for like, you know, parsers and compilers and stuff. Like they contain a lot of algorithms, but they're always a little silly. So anyways, let's go. So the current, so we then essentially just iterate through. So we say, you know, for C in str, and we probably need to do that. I know we're doing chars twice, but it's gonna be fine. I think we want a current count as well. And so I guess we would go, we start at 1, and we say, okay, if C is current, then current count gets increased by 1, right? And else we can then write that down. So writing it down will right now just be result. And this is very slow, but we will just do it like this, and then we'll improve it later. So we'll actually push two things. We'll push the amount of characters, and then followed by the actual character, right? So we're gonna do current count current, right? And is that like append? No. Push should be fine, I think. Yeah, it's not great, but let's pretend this is fine. Okay, and then current is C, right? And the current count sets to 0 as well. And I think at this point we're done. We just return the result, and I think that should be it. So now let's write tests. Did I write that right? I did. So we use super. And so the reason we write tests instead of writing like some command line app is because these are much more sort of usable, right? Like having tests is documentation. It's having safety that like the feeling of safety that your shit works. A couple things like that. So cargo clippy. Okay. It doesn't look like Clippy is actually working in the editor, which is a little annoying. Sorry that I'm doing this in the video, but like, I just want this to be annoying and oh, I think allow is the wrong one. Yeah, I think annoying. I think this is the wrong, like allow would have been the wrong one. That's what I meant to say. I don't know what I said. If I get rid of this, will it now warn me? No, I have to probably configure that in Z. I'll do that real quick. All right, I figured it out. Fantastic. So the setting was, in case someone wonders, the setting was God, where is it? Oh, I probably already lost it. There it is. It's initialization options, check on save command clippy in case anyone is using Z. I don't think so, but there it is. Okay, so we can do this when, what was it? Next. Okay, that's fantastic. So I think we can still optimize this a lot, but let's first write the test, as I said. Test function encode text normal, and we're going to just let text hello world, right? And this should literally just encode hello world in like this annoying format that we have. So let's do that. So let result is encode text, and then let expected be 1H, 1E, 2L, 1O, 1 comma, 1 space, 1W, 1O, 1R, 1L, 1D, and 1 exclamation point. And then we just assert equal expected result. And cargo test, and it fails. Because it starts at 0, right? Because the current count is always 1, actually, so that's what we want. And it stops before the last one. That makes a lot of sense. So we need to do it again. But we only need to do it again if the last one is not a repeating one, I think. Right, let's see. So it's now different because it actually thinks that there's 2 H's. That's a good point. So I think current is supposed to not be a thing in the beginning. Yeah, I think we start with a count of 0, right? That's what we have to do, because otherwise it's going to, yeah, okay, so that's fantastic. Now that test passes, but I think there's still encode text ends with repeat, because I think if it ends with something that repeats, we're actually kind of not doing the right thing, right? So this is like a classic example, right? So let result be encode text, and then we have let. So we expect it to be for A, for B, right? That's what we expect. But I have a sneaking suspicion that this is not going to actually work. Interesting. So I think it does work, even though this is a weird like algorithm, like the way it's written, it's a little fucked. So let's see if we can redo that, but only once we've written a couple more tests. So let me write a couple more tests. We need to cover some edge cases, so encode text edge cases. These are like really weird edge cases, so we're gonna assert equal. Immediately, we're going to assert that this is going to be encode text empty. One with only an A is going to just be on A. And then a, what other edge cases are there? Oh yeah, also the double A case, which is a different case, I think. So these are all, yeah, these all pass, okay. Fantastic. Oh, of course, we need to test against, why do I keep typing that? Encode text case. So the case sensitivity is, of course, absolutely required to like, we cannot mess up case sensitivity because that would be wrong. So let's do that. So this is 1A, 3A, 1B, 3B. Make sure the case sensitivity is right. It is. Okay, fantastic. So this all works fine. Now that we have tests, and this is the usual way you should do it, is like, okay, you write your algorithm in like a stupid way that works. You write tests, and then you figure out, okay, how can I possibly make this better? Because right now, this seems slow, right? So first thing would be to allocate this with the capacity of at least the string's original length. because in the good case, we're going to have a shorter text like here. And in the worst case, we're going to have at least that much anyways. So we might as well allocate that beforehand. And right, so that's the first thing we can do. The second thing we can do is this. So right now, our algorithm is, okay, we look at the first one, then we iterate through, and then each time we push it when we have found sort of the result, right? And this is a little weird because we're allocating that, even though I don't think we need to allocate that. So because, like, and this is a micro optimization for sure, but what if we do 0 plus current count? Because surely, oh, this cannot do that because as usize, or actually, I think current count. Oh, actually, no. This algorithm is not good yet. Let's write another test that will fail because I have a test that will fail. So the test that we have had previously when I was explaining stuff was 5, 6, 7, 8, 9, 10. So this should be 9A, 1A, 4B, right? Because this is more longer than 10, because this needs to split it up because we cannot fit that otherwise, right? And this is going to fail because it actually does 10A 4B, but we cannot decompress that, which is important because we don't know like how many, right? So we need to have a limit in here that like if C current and current count is less than 9, then we can do that. And else we need to do that, right? Because otherwise we're going to fail. And now it works. Okay, so that's an important little thing. What other edge cases do we have? So this probably covers all the cases that we have here. Let's grab one of the Wikipedia cases, maybe this one, because I want to make sure that whatever they are doing is the same as what we're doing. Encode text Wikipedia. Let's call it Wikipedia. That text is that, and then the result be encode text, and then the expected be whatever this is, and then we assert that they're equal. And again, this is just like a thing that we need to do in order to make sure that our code does exactly what we want. And oh yeah, no, this is actually not correct. This is not correct because this is a special case where it's longer than that. Yeah, good thing I looked at this because this is actually the one where it's wrong. Yeah, this is the one where it's longer than one character. So so this is actually not one we want. Let's comment this out. So is there not comment? What's the shortcut for that? I've never done that. I don't usually comment out code because it's usually in the commit history anyways. Oh, GC, fantastic. Okay, so let's try that again. So this is supposed to fail because it's not correct. Let's write that in here actually. Correct. Okay. So far, so good. Now let's change this algorithm a little bit. So I think the first optimization I would do is to get rid of the format, because formatting here means allocating a string just to then push it, which is a little weird. So is there any other way to add things to this? There is insert. Okay, that's not bad. How about we just push a character though? How about we push the character 0 plus the current count as char? Does that work? Because I think that's what we want, and then we can just push the current char. And that should do the same thing. Let's see if that broke the tests. That did break the tests. Oh, char from, yeah, of course, it makes sense. I don't know why I thought that would work. Is there like add? No, there is not. Okay, char from U30. Oh, from digit. Interesting. I think this might already be what we want, right? So current count. Is there like a 2-digit or some shit? Because like surely a chart or a digit in the given radix. So hold on. Which direction is this? This is from U30 to from digit. So this would be converts a digit in the given radix to a char. Use char from digit. What? That's exactly what I'm using. Oh, sorry. This is what I want, right? Okay, basic usage. Oh, that's exactly what I want. Yeah, okay. So we want current count 10. That's fantastic that it has that, because I was going to say, like, I really don't want to write code that allocates like that if we can avoid it. So that didn't work because char from digit can fail. Can it though? Because we know these are valid. So we can expect these to be. Now, I don't know about the last one. Let's add a test that also tests the last one. Longer than 10, and this is ends with longer than 10. Oh, closed it. My bad. Because it's okay, it still doesn't work. Current count, try into unwrap. Yeah, of course we need to try into this because current count is the wrong type, but I think that's just the case because we're a little silly. So let's just make it the right type. And that worked, fantastic. So it looks like our little algorithm here still does handle this. Now, if I add another one, just make sure that that still works. Yes, okay. Okay, so that's a little better because we don't allocate a fucking string in the middle of this. So now we just push twice, which I don't know what push does. It reserves and then it just encodes it, and then yeah, that's it adds it. Okay, yeah, that's fair enough. That seems to be fast enough, I think, for me. Now, what else can we do? I think that's pretty good. I don't like this that we start with like the first one, but it's not the end of the world, right? Because okay, so this is guaranteed to work because it's not empty. The count starts at 0 because it immediately gets incremented to 1 if it's there still, which it is. So I guess we could skip the first iteration a little bit. The only issue is that I'm not really, like, we need to initialize this with something, right? And I don't like that these are mutable either. So how about we try rewriting this in a, can we rewrite this in a better way? I think this is fine. I think it's fine. Let's move on to a binary method. So encode data. And this is going to be data, and we're just, oh, what did I do? Oh, there we go. I've never been so confused by my own system. So we'll just have a bunch of bytes and we'll return a vec UA. And this is where it gets sort of truly interesting. Because I want to, like, here we can actually have proper encoding. We don't need to worry about this. We can have 255 of them, stuff like that. So how about we start with if data is empty and we return vec new. Okay, so then we do, let's start with the loop. So can we, what if we iter over this? Let's see if we can do something here. So I guess we want to, what do we want to do? There should be a way to like do this algorithmically in a way that's a little like, this is ugly and shit, but this is just our text method that doesn't really matter. And realistically, this should just call this, right? But let's see. So we walk over all the data and we essentially want to keep track of how many we've already seen of each type. No, we don't. We just want to store with each type how many. So we essentially want to do this. But what is this? What would you call this? You would call this a. So this is a filter. Right. Well, you could rewrite this. You could actually, let's rewrite this. You could rewrite this to essentially get rid of this check a little bit, or maybe invert the check. Do we want that? I don't know if we want that. So we could instead of doing this, we could keep track of the current count in that part of the array. So I guess we could have sort of build a new array to, like, we keep looking at the index of the current count and the current digit, and we keep writing into that. But I don't know if that's makes it easy. I don't think it makes it easier at all. Let's actually hold on. Before I do this, and let's get rid of the failing test here. Let's commit this. Okay, so now that this is committed, we no longer have to worry about losing it. Let me rewrite this. Let me see if I can do something here. So what if my result, and let's make it mute for now. I know that's not everybody's cup of tea, but what if we make a vec and the current and current count don't exist, and with capacity strlen. Oh, and instead of doing this, we do, have we seen this? Like, is this the same as the one that's currently in? So if C is equal to result last, yeah, see, this doesn't really help us much, I don't think, because this only makes it harder to reason about. I was thinking maybe something reveals itself to us once we do that. But I don't think, because like it's also gonna be like, you know, result dot take something. No, let's not do that. How about we don't do that? Here's a fun idea. Let's not do that. Does it not show git changes anymore? Whatever. Okay. I don't think Rust Analyzer likes what I'm doing here. Anyway, so this seems like a tough algorithm. Okay, let's see how they do it. So chain from iterable. So chain is something that they have. No, it has nothing to do with it. This is it. So we give it an iterable, and we say, okay, we put the length of G in there, and this is irrelevant. This is completely irrelevant. So we do this for K in group by. Okay, so yeah, group by. Okay, so is there a group by in Rust? There probably is, right? So let's do str group iter group, or actually chars iter group. No, iter. There is some sort of like, I guess we could fold. Yeah, we can fold. That's what this is. That's what I've been thinking about. Yeah, that's the thing. Okay. So this is a fold, right? We do str chars fold, or maybe it's an R fold, because we have to fold from the back. I guess it doesn't matter which direction we fold. Okay, so this is a fold. So the init is going to be string with capacity strlen. and then we fold. Oh, whoops. I don't think that's how this works. This is two things, right? Yeah, this is two things. So what are these? This is accumulator and the current value, I think. And yeah, so now this becomes interesting, right? And I think we want to R fold because that way we can do it in reverse. No, we don't want to R fold. We want to fold because we want to do it the correct way around. Okay, so this is interesting. So there's no last. So I guess we want to probably just have a vec because I don't really trust this otherwise. So ac last. So this is a last chunk. I essentially want to chunk it by 2 because it's always going to be 2, right? So so this is the last chunk. Let's put it to do in here so it doesn't error the entire time. And then we essentially have 2 of them, right? We have 0, which is the count, and the char, which is chunk 1, right? Oh, sorry. Yeah. Am I crazy? Oh, it's an option. Okay. Right. So count, and this is a 2. This is a chunk of char 2, and then we can get rid of this explicit shit. And it's actually this. So these are just aliases. So if the count, and actually we want this to be mutable, don't we? So this is a little bit of a weird algorithm. I'm gonna have to admit I'm not doing a particularly good job at this, but it is very funny. So can we mute this? Is that what fold allows us to do? I guess it does. I guess it does. Okay, so if per equals char, then we just count plus equals 1, and it doesn't let us because count is, this has to be mute, doesn't it? And then this is also, oh yeah, we need to reference this. And it's still, whoops, mute. Am I going crazy? Oh, cannot use that. So this is now, count is now, so char 2 digit count. I think 2 digits is what we want, right? It takes a, oh, it's like, dude, I am so cooked today. 2 digit 10 plus 1, and we do char from digit. And it doesn't like this because this can fail, and this can probably also fail. Cannot be dereferenced. Yeah, I know. I'm not trying to dereference it, buddy. Okay. So this seems fine. Borrow is later used here. Yeah, no, I get that. I get that. I'm not doing it right. So how about chunk 0 and chunk 0? So this is essentially what we want, right? it's a little weird because this should probably be chopped or something, because like it's a little tough to read. So new count, and then this is new count. At least it's a little bit easier to read this way. And else, and this is where it gets interesting, so now it's the same, right? And else we actually get rid of can we drop the chunk explicitly? I don't think we need to. But essentially we want to return ACK, right? But we want to say, is this how code works actually? Let's see. Yeah, it's correct. So instead of doing anything else here, we do vec push, ACK push, where we push two values, or extend from slice is probably what we want. And the slice that we're extending from is going to be the 1, which is char from digit 110, or actually we can just 1. And then the character that we're looking at, which is char. I think this is the same, and it's a little cleaner, I think, because it's easier to like see, okay, we're folding over the characters, fair enough, whatever, you know what I mean? And what is the result of this? And yeah, I think the result of this is just wrong. So I think we want to do, so this is the let result. And I think the next step is then to do string from UTF-8, where we take the result and we do unwrap. Oh, it's a vec of char. Interesting. How do we convert a vec of char? Can it into? No, it cannot into. Vec char to string. Already almost an hour. Oh, it's vec iter collect. Okay. I could have probably figured that one out. Okay, so as much as this is a little weird, I think it does make a lot more sense. So now if we, oh no, if we, instead of calling this chunk, we call this like the pair, right? And we say, yeah, I think this makes a lot more sense. So this is the new count. We then assign that to the pairs count. And yeah, I mean, this, you could argue that this is uglier, but I think this makes a lot more sense. And it actually fails on all accounts. That's fantastic. That is very funny. Oh yeah, because this, right? So this actually does not work like that. This does not work like that because we need to we need to probably just if let some pair equals this, then can we specify the type here? No, we cannot specify the type here. Okay. No, I think that's not what I want. I think I want to just if ACK is empty, or if it's not empty, then surely no, it's okay. Just do this. It's a little weird. It's a little deep. I think the previous algorithm was maybe a little nicer. Non-value. Oh yeah, it cannot unwrap this to a digit because God knows why. So I tried it with a fold. It's not better. Gotta be honest. I thought it would be better with a fold. I thought it would be better with a fold. I think it's still going to be better for the other algorithm. I just think that we can get rid of it for this. There it is. Because I just don't think it was that good, you know? This pub function encode data. And I think here we can definitely use that because it's like now we have data, which is U8, and then we return a vec of U8. This seems to really kind of make sense, right? So if data is empty, we return vec new, and okay, so now this is actually different. So we no longer have string.length, we have now data.length, and this is data. We don't need that. Does that work? This opening brace is not closed. Yeah, I figured that out. Thank you very much. Okay, so the fold doesn't exist because we need to iter. Oh, can we into iter? Who cares? Yes, we can. So extend from slice one char. Let's just to do at the end here so it stops complaining. Okay, and then of course this is U8. Last chunk, mute, expected integer for U8. Yeah, so this is actually a vec with capacity that, and what's cur? It's U8, so fantastic. And then again, we need to dereference it here. We don't need to do this whole damn shit. That's all stupid. And then again, we don't need this. This can just be new count +1, aka pair +1, not new count +1, but like this is literally just that. We can do that, and this becomes like quite. This is what I mean. Like this is what I imagined the other code would be like, but the fact that it's a little cringe kind of takes away from that. And I think the is empty case is not very nice. So I think instead of having it start with vec capacity blah, we'll actually pre-initialize the vec. Because I think the vec should start with the first element. It just there's zero reason for it not to, right? And then we'll fold over the vec and we can get rid of the special case, which is pretty fantastic, I think. Yeah, of course, this won't consume. Thanks, Clippy. See, this is the type of shit where I need this. I think that's actually enough because at this point we can probably just collect, or maybe we don't even need to collect. Yeah, that works. Because I feel like that this is nice, but this is way nicer. You know what I mean? I think the last chunk mute can still be made better because we kind of guarantee we never push anything that isn't literally these. Can I inline this with the initialization somehow? No, because it feels. Oh, yeah, of course I can. Of course I can. Let mute v is vec v v. Then we don't have to make it mutable. And I don't know if we even need this. Oh yeah, no, we do need this case because that's still the is it empty case. Okay. we didn't break anything because we didn't write any tests. So let's write some tests. And then we're kind of done with run length encoding for today. Encode beta normal. Let me check if I have any messages. No, I don't. Fantastic. So our data will be 1 0x 1 0x. Well, let's do the same thing we did in the other one. Or let's use like A, B, C, D, and E. And then we'll do result is encode data. And then we can do let expected vec. And we expect 0x1, 0x A, 0x1, 0xb, 0x1, 0xc. Actually, let's not write these as hex, so we can kind of keep track of what we have. 0xd and 1, 0xe. And we assert equal expected result. And it fails because we have, yeah, again, this mistake. Fantastic. Okay, run encoding works on this as well. Encode data. What else do we have? We have edge cases, we have text cases. Yeah. Okay, so let's just do edge cases where we just assert that it's empty when it should be empty, stuff like that. Encode data. And this is not, oh, interesting. Oh, is that, what the fuck did I just do? Okay. Is that not how that works? Oh, my bad. Okay. And then, oh yeah, and now we can do it. So this is now vec 0x1, 0xa, where we just have one character. That's a special case. And then another special case is when we have two of them right beside each other, which should be, my bad, that's wrong, 0x, 0xa. And mind you, we have not implemented decompression yet, so we'll do that next, I guess. But yeah, I think we can confidently say that this works now. I don't think we need to write many more tests. Let's write one actual test, and then I think we're good. Encode data log. So let data is, and now I actually do want to use Copilot for this because I don't want to write this out, to be honest. Yeah, let's have 12 A's. And yeah, this is not how I want it to work, right? Because we no longer have that check in place, which is actually a problem. It's actually a problem because we want, okay, so this is like normal, right? We want to essentially have this say 12A, right? Because this is no longer limited by that weird limitation. But if we have more than 255, we're going to actually run into probably a panic very long, which is going to be like 300 of them, where we actually want 255 A's followed by 45 A's. But that's actually going to overflow because we're trying to add with overflow. So we need one more check in here where we essentially say if current is pair 1, oops, what did I do? If current is equal to pair 1 and pair 0 is less than U8 max. Is there not max? I think there's, yeah, there's max. Yeah, now it works. Because that should put it into two things. Okay, so that's very, very, very simple run length encoding. Let's write a little run length decoding next, and then we're going to be done with this video. And if you're still here, you're a fucking trooper, because I don't think, according to my statistics, anyone's still watching, but I hope they are. And if you are, thank you. You're the best. Decode data. Data U8. Back U8. And this is going to be essentially the same thing. Not really, actually, not really. So we take the data, we say data.chunk. Oh, wait, look. We could have done this. We could have done chunk by. Ooh. Oh, do I nerd snapped and fix that? I think I get nerd snapped and fix that. Let's add binary encoding. Okay, but see, I feel like sometimes that is a really an idiot. Okay, so instead of folding, I think we could chunk it. What does chunk do? So like data chunk by. We can. I feel like this is probably the same, right? We still need to split them. I don't think that makes sense. Actually, let's not do that. So pop function decode data data U8. Back U8. Now the idea is we essentially just walk over it. We say data chunk. What's the difference? This. So we have our pairs. That's what we call that thing. And that's data chunks, and that can probably unwrap. No, we cannot. I think we just wanna have a new thing. So pairs. I think we want to fold again. I think we're back to folding, because we want to fold on the vector, right? I think we want to fold on the vector. At least that much we need. This is not optimal, by the way. In case you ever wanted to you want to implement this yourself, like please don't do it like exactly like this. It's a little much. Okay. So, and essentially we want to extend from slice where I guess we don't want to do that. Let's see. What's this? There is repeat, right? Isn't there? So I think the clean way to build this would be to say, okay, let count char is cur on. What is that? Like deconstruct? Isn't there like a deconstruct? I don't know. 0 cur 1. Maybe I should have done that up there too. And then what to do. Because realistically, this isn't going to be that great, but whatever. So extend from slice, where essentially we just want char repeat, or can we like act.repeat? Creates a vector by copying a slice n times. Yeah, I think that's what we want. So I think we want to, at least for like the primitive version, right? We want to essentially repeat this count times which is kind of enough already. Because like what's this? This is it, right? This is just repeat the characters, extend that, you're done. So let's try that. So test function decode data normal. And I don't know why I keep calling it normal. It's not that normal. Whatever. So this is going to be hello. We then do encoded is encode data data. We then do decoded is decode data encoded. And we then assert equal that data equals decoded, or I guess, yeah. And this does not work because they are, it's not a movement for vacuum 5. What? What are you talking about? Oh. They both have to be slices, I reckon, for this to be comparable. No? Okay. Yeah, that's what I wanted. Cargo test. Yeah, that seems to work. I mean, it's not very fast, but I don't think we need fast right now. I think none of this is particularly fast. This is longer. Also works fine. So we encode it, at which point it's whatever, and then we decode it, at which point it's this again, and then yeah, seems to work fine. Okay. We also need the same thing for the encode text. But I think that kind of explains itself at this point. So decode text. I think this is going to be a little awful, but encoded text str, we return a string. We do vec with capacity is correct. We chunk the text. Can we not iterate? My God. Into iter, I guess. Can we not chunk it? Please let me chunk. What the fuck are you doing? Did we not use the same thing here? No, we did not. Oh, yeah, we did not. My bad. So it's not that simple, actually. Do we implement the primitive? I think we implement the primitive one again, just for that, because it seems like it's we could one shot it with the AI, because I don't think we're learning much at this point. But let's indulge anyways. So if text empty, we didn't do the empty check here, by the way. And I reckon this is also going to not work very well if it's not actually a correct format or whatever, but we didn't check that and we don't care. Okay, I have 29 notifications somehow and I don't understand who's talking to me this much at this time of day, but I guess we'll find out in a second. Oh, it's a group chat. Okay, never mind, don't care. Okay, so take a sip of my cold coffee. All right. So data's empty. Text is empty. Return string new. This makes sense, right? Like empty is empty is empty. So now we essentially just go over the data. We do. Can we really not chunk it? Is there no like chunking? Okay, so rest chunk chars. What the fuck is this? Oh, I have to collect it into a vec. Don't care enough to do that actually. I think we'll just do it really simple. For I see in texts iter, no, chars enumerate. Is this the right way around? Let's check. Isn't there like this thing I can put on? Yeah. Okay, it's usize. Fantastic. So we then have a let mute result string, and I'm not proud of these, and I think we can optimize them. But I don't think we need to optimize encoding that much. Like the question of how can you is quite interesting. Like I'm sure you can optimize this by getting rid of this allocating, potentially this definitely allocating. You can get rid of this, probably doing something stupid, and this branches a lot. I don't know, like there's probably stuff you can do, but I don't think that's the focus of today's episode as much because we're already an hour 16 in. So what can we do? Okay, so so I guess we essentially want to push. So we have two things, right? We want to go always two. So let's write this ourselves. I don't really want to do this like in a weird way. So we start at 0, and we just say we loop while I is less than text len. And we do I plus equals 2. So this is essentially a chunked thing. And that's at the very end. No. Okay. And so now we say, do we take the current? So let's just do the same thing we did up there. So let count char is text chars. Let's store the chars somewhere. So it's a little easier to read that way. So chars get, or what is it? At nth, it is nth. I, and the other one is I plus 1, right? So no, it isn't. Start at 0. Yeah, it is. Yeah, it is. So we need to make sure we actually only iterate to there. And I plus 1. And this doesn't work because it wants to be mutable for some fucking reason. I don't want to mutate this. Am I not trying to mutate? Am I crazy? Oh, okay. I guess nth mutates it. What? Why does nth take a mutable reference? Oh, because it consumes it. Ooh. I guess we have to collect it anyways. That's very annoying. I don't really want to deal with that. Can I not just index the fucking string? What's the panicking version? Oh, can we just index it? Is that really a thing we can just do? I think it might be. So text I plus 1. No. Okay. Whatever, dude. I'm tired. I'm tired of this fucking the whole text chars thing is really bad on Rust. in case you haven't noticed. Simply because there is no way to like, okay, so there's a couple things, right? The first issue is that chars are very large in Rust because they encode an entire UTF-8 thing, instead of just, you know, being like something normal. What the fuck is that? Oh, it's a slice? I don't, oh my god. Can I not just get a single element at char? I don't understand why this is such a fucking pain in the ass. Because like, okay, I have an idea. I have a fantastic idea. Our chars is just going to be text, where is it? Slice. What is it? Chars. Not s slice, no, chars, s. What the fuck is this? Oh my fucking god. Can I not just... Can you not just index an str? Yeah, char's nth is dumb. I know it's UTF-8. I know that makes it harder. I know that. Oh, as bytes is what I want. Yeah, thank fuck. Jesus Christ. Because I don't know. Oh, actually, I don't really want as bytes. I don't want as bytes. Oh my god. I do want chars, don't I? We'll collect it and we'll just call it a day. Oh my god. This is such a pain in the ass. I don't know why it had to be that bad. Like, I don't get it. It's genuinely baffling. Like, I know why it is this bad, but I don't understand why it necessarily had to be. You know, like what made them go, we need to keep this API the way it is, and we need to have a char be like 8 bytes or the fuck. It's really bad. Like you would think that each char is like 1 byte. A char is a, where does it say? It says somewhere, hold on. The size of a char is definitely fucked up though. Like if you mess this up, oh yeah, it's 4 bytes. So each char is actually 4 bytes. So if you wrote this same algorithm for ASCII, mind you, in C, it would use 4 times less memory. Interesting. That's interesting. You wouldn't handle UTF-8, but maybe you don't want to. You know what I mean? Like maybe we don't care. In this case, we care, but like it is very funny. So from digit count 10 unwrap, and this of course doesn't work because somehow this is not the right thing. Okay, and then we essentially just want to do a result. Can we not append extend? Yeah, that's what I want. Extend, just then char as, is there no str? Okay, we can't repeat that either. Okay, well in that case we're just going to do the same thing, where we just repeat it count times and we're gonna be done. And this is size. Like, okay, is this dumb? Is this really stupid? Yes. Is this gonna work? Most likely, yes. It's most likely going to just work. And we spent, oh my, almost like 15 minutes on this, so yikes. Okay. Test function decode text normal. And this is the fun part where we actually get to write text. So text is, hey there. Why? right? And then we say encoded. And again, I'm gonna turn on the AI because I don't want to write this myself. It's very clear what I'm trying to do, and it doesn't work because we are panicking at from digit. Oh, it's a 2-digit. Is it two? It's 2-digit. That's probably what the issue was before as well. I'm gonna guess that's what the issue was before. Okay, yeah. So that works. I don't think I want to write many more tests for this. Let's cover the edge cases as well. So let's do function decode text edge cases. And again, we're gonna let the AI cook this one up because I don't want to care to type this out. Yeah, looks good to me. And of course the error handling is not in here, so it'll just crash, but it is what it is. That looks pretty good, works fine. Didn't quite make something that's publishable yet, but it's good enough. So let's make a little repo. Actually, we need to do that in Firefox. So I'm trying to launch Firefox without leaking every single website I've ever visited because it's private. There we go. Okay, so this is my GitHub. Let's make a new repo. This is gonna be RLE rs run length encoding for text and data and Rust. If I could spell run length, that would be good. Let's create that. I don't want Copilot to build it. Thank you very much. Push that and we're good. There it is. RLE RS. Horrible, horrible thing, but it does work. So thank you everyone for watching. If you enjoyed that, make sure you leave a comment saying yippee, yeah, I made it. And yeah, have a fantastic day.